Hello everyone, this is a video for lesson 1.4 about writing a hypothesis. When we write a good hypothesis, it's going to allow us to understand our experiment better. So the better we write our hypothesis, the better we understand our experiment, we can set it up and understand the structure better. So it's really important we do a good job here. All right, so let's jump into it. I see a red ribbon, so we're going to write this down. This is our word of the day, actually. A hypothesis predicts the results of an experiment based on previous observations. So that's our definition. Let's kind of break that down a little bit. So first off, a hypothesis is not a guess, it's a prediction. So we're not just throwing the old adage is just throw spaghetti on the wall and see what sticks. We're not going to do that. We're going to make a very measured prediction and not a guess, not a theory, not a hunch. Secondly, we want to include our independent variable and our dependent variable, and we're going to try to compare those two. Number 3, we are going to write our hypothesis as an if-then statement. And the final thing is we're going to base our hypothesis on prior knowledge and observations. In other words, we're going to use science to help our prediction. So I went through those quickly. Let's write those down. And I'll pause for a little bit. But you can pause your video player and just write these down. These are going into notes. So number 1, a hypothesis is not a guess. Number 2, a hypothesis includes the independent and dependent variables. Number 3, a hypothesis is an if-then statement. And 4, a hypothesis is based on science. So pause it now. I'm going to go to the next slide. So I threw a little experiment together when I went running. I thought I would consider what kind of music would change my speed. So like if I listened to faster tempo music, some Black Eyed Peas or with a little boom boom pow, So I was getting my boom boom pow on and was wondering if it would make me run faster than some slower tempo music. So I wrote a scientific question that says, how does the tempo of music affect my running speed? Now, you've seen these before. I'd like you to take a moment and pull the independent variable and dependent variable out of that question. I will pause for a moment. You can pause the computer. Okay, here we go. Remember, the independent variable is first. It's the cause. And in this case, the tempo of the music is causing the speed to change. So my independent variable is the tempo of the music, which means my dependent variable, which is going to be in this question, okay? It's going to be in the question, and it's going to be affected by the independent variable, and that will be the running speed. Now, I want to come up with some reasoning here. And let's consider the prediction, and then let's use the reasoning to make the prediction. In my experience, the faster the music, the faster that boom boom pow, I get more pumped up. And if I get more pumped up, then I get fired up. And if I get fired up, I'm going to react. I'm going to throw my hands in the air. I'm going to bounce around the room. So it makes sense that I would also run faster. So my reasoning is that when I hear faster music, I get pumped up. So if I get pumped up, I'm going to run faster. Now, we are going to put these 3 items into our hypothesis structure. Now notice, I'm not going to write the actual ideas in. I'm going to put the structure together. Let me show you what that looks like. So I'm going to write if the, and then I'm going to put in my independent variable. Okay, and by the way, that you see a red ribbon, this is going to be written down in your notes. So if and then the bracket is whatever my independent variable is. Then I have to describe how my independent variable changes. Quite often it's going to be an increase or a decrease, but it could be something like, it could be like if I listen to a different type of music. So then the next item would be my then statement, then the dependent variable. Okay, and I put in the brackets is my dependent variable, but in this case it might be, it'd be my running speed increases. And I'm going to talk about how that dependent variable changes. It's either going to increase, decrease, and it could just stay the same. And then we have to describe the science. So it's because we describe the science. So if the independent variable changes, then the dependent variable also changes. We have to describe that change because science. We describe the science. So take a second, finish writing this down, and then go into, and we'll talk about the next slide, but then press play. I'm going to, well, let's go to the next slide here. All right, this is noteworthy. I want you to, so we're going to write this, what we just wrote down, all in one sentence. If the independent variable increases, then the dependent variable will increase because describe the science. All right, so I put increases, but it could be decrease or it could be stays the same. All right, I'm going to go, make sure you get this in your notes. I'm going to the next slide now. All right, so let's take our, well, I already pressed it. If the music tempo increases, then my running speed will increase because when I hear fast music, I get pumped up. We have in the orange our independent variable. We're talking about increasing the tempo. Then in the blue, I have the dependent variable. My running speed will increase. We could also say my running speed will get faster, but we want to, if we can keep it to increase or decrease, that makes it a lot clearer for us. And then when in the green is my reasoning. It's my because, it's my science. When I hear fast music, I get pumped up. So remember, going back to the prediction, we're making a prediction based on science. We're not making a prediction based on what sticks to the wall. Written a hypothesis. Let's talk about one other thing, and that is the control variables. A control variable is any part of an experiment that stays the same, boldface, same throughout the entire experiment. So I want to really emphasize that word same. Every time we do an experiment, the independent variable changes, the dependent variable changes, but everything else stays the same. Please write this down in your notes. All right, so in my running experiment, let's consider some of the control variables that we would need to consider. So I hope you came up with a little list. I'm going to give you an example, a couple examples that I thought of. So first of all, we should run the same course. I can't run a hilly course the first time and a flat course the second time. Eat the same type of food. Same type of food before I run both times. Same amount of water I run before both times and during. Same running shoes, same clothes, same glasses, same everything, same headphones. Can't be changing out the headphones. And use the same timer. So these are some examples of controls. Every time you do an experiment, if you identify the controls, your experiment will be a lot cleaner and a lot more, it'll make a lot more sense. So this concludes the video. Thank you for watching. We're writing hypothesis now, and we can identify controls.